Hello everyone, me your friend Krishna Kumar Chaudhary came with the content that is product of four vectors. In the vector we do have two types of product. One is the scalar product which is called dot product, and next one is vector product that is called cross products. So we are talking about the four vectors. So let's talk first one is scalar product of four vectors. So scalar product of four vectors. It's clear from the heading that we should have how many vectors? Four vectors should be there. So suppose that four vectors are, let a vector, b vector, c vector and d vector are four vectors. No, then dot product or cross product between what? Between a, b, c, d, okay, is denoted by a cross b dot c cross d, or a dot b cross c cross d, or we can say a cross b, after then cross c, and then finally with d, is called scalar product of four vectors. No, scalar product of four vectors, and this scalar product of four vector obviously will be the scalar quantity. Understood? So after then we have next content. It's clear from there, just scalar product between the four vectors there must be a dot product. No, might be between two or single, anywhere. No, that is called a scalar product of four vectors. Now we have expression of a cross b and then dot c cross d. No, so for the expression, suppose this, let a cross b, a vector cross b vector equal to m vector. Suppose we have, suppose this a cross b vector is your m vector. No, then what will be the, then a cross b, this expression you are going to find out. No, this one, a vector cross b vector and dot c vector cross d vector. Substitute instead of a cross b vector that m vector, so m vector and dot c vector cross d vector as it is. No, and we know that dot and cross can be interchanged. No, you can keep dot here and cross here. No, so cross here between these two and dot at last. So we know by this is what this you have this, it came by the changing of dot and cross product. Okay, now substitute the m vector, that m vector you have substituted that a vector cross b vector, from where you have assumed. No, m vector is your a vector cross b vector, and cross c and then dot d vector, okay, as it is. No, and this is what, actually this is three product. No, vector product of three vectors, but we have how the formula is, this single should be in the front. No, so bring here, interchange this one. So obviously in the vector product, if you will interchange, the negative will be, and c vector cross a vector cross b vector as it is, and dot d vector as it is, negative as it is. Now in the next step, and what will be the c cross a cross b vector formula or expression, that is c dot b and then a as it is minus c dot a and then b as it is, and d remains same. Okay, and after then let's multiply with this sign, minus sign. If you will multiply, obviously this negative will get positive. No, negative one will get positive, so it dot here front. No, and b dot d minus, this will be the negative, then first term will be negative, minus c dot a and then a dot d. So arrange it, let's arrange it. We know that dot product is commutative, so c, instead of c dot a we can write a dot c, b dot d as it is, minus c, instead of c dot b we can write b dot c, and lastly a dot d same. This we can write in the determinant form. So writing in determinant form, you will get a dot c, a dot d, b dot c and b dot d. While calculation of vector product of four vectors, scalar product of four vectors, we can compute by the determinant way. Okay, we can compute by the determinant way. So this is the expression of a vector cross b vector and dot c vector cross d vector. Now let's study about the what scalar product is this. Now let's study about the vector product of four vectors. So for the vector product of four vectors, we suppose four vectors, you need to suppose that four vectors are a, b, c, d. So let a vector, b vector, c vector, d vector be four vectors. Then vector product or cross product of these vector, that means these vector means four vectors, are defined by, how will you define? A cross b cross c cross d, or a cross and then b cross and then c cross d. No, or first you should do cross between c and d and then b, and lastly you should do cross with a. That will be your expression, you can say. That will be way of calculation of vector product of four vectors. No, now we should have the expression for four vectors, as a scalar product has expression of four vectors. What will be the expression for the vector product of four vectors? So we are going to find the expression for this type of vector, a cross b cross c cross d. We can find in this vector expression even, but it will be different from this. Now we are going to find this expression. So for that, let us suppose, if you will suppose a cross b is your m vector, then what you will get? Then a cross b cross c cross d you are going to find, no, which is equal to, instead of a vector cross b vector, you have written m vector and cross then c vector cross d vector as it is. No, then what you will obtain by the vector triple product, m dot d and then c minus m dot c, and lastly you have d vector. Substitute the m vector, that you have a cross b substituted, and dot d vector, this all as it is, minus m vector substituted, dot c and then d as it is. Now as we know that dot and cross can be interchanged, let's interchange this one. No, so a dot b cross d and then c, and minus this, change it, a dot b cross c and then d. Then what is this? This is a scalar triple product, so we can write it a b d and c as it is, minus this we can write a b c and d vector as it is. No, this is your expression, or we can arrange it. No, you can arrange it, or this is your required expressions. This is your required expression for the vector product of four vectors. Now if you will suppose this c cross d vector as a some next vector. Now we let us suppose this c cross d is your n vector, then what will be the expression your? Then we are going to find the expression of this one, a cross b, a vector cross b vector and then cross c vector cross d vector. So this expression, a vector cross b vector as it is, cross n vector. No, and cross n vector is, now we know that where we will apply the vector triple product, obviously this single should be in the front and then second should be in the last. So change it. Then obviously if you will bring this one front, then negative will be, no, and cross and then this as it is. And now vector by the vector triple product, what you will get? N dot b and then a minus n dot a then b. No, and minus as it is. Let's multiply with the minus in the next step. If you will multiply this, you will get the negative one will be the positive, n dot a then b minus n dot b and then a. Now substitute the n vector, that you have c cross d dot a and then b vector minus c cross d dot b and then a vector. Now and let's interchange this dot and cross in the both places. You will get c dot d cross a and then b minus c dot d cross b and then a. Just we have interchanged the dot and cross. Now this is the by definition of a scalar triple product, we can write c d a b as it is, minus you can write c d b and a as it is. Now arrange it. Now a bring front. Let's bring here a front. So first time change, then negative will be, one more time change, then again negative into negative positive, no need to change the sign, a c d and then b minus this again, twice time you have changed, no need to change the sign. If single times you will change, then it will be the sign will be the change, b c d and then a vector. This is your required expression of a cross b cross c cross d. No, so after then you have next topic, that is the reciprocal system of vectors. Now it is applied in the three vectors case. Reciprocal system of vectors is applied in the three vector cases. So first, for that, let us suppose three vectors. Let A, B, C are the three vectors. No, those vectors are non-coplanar set of vectors. Then reciprocal system of vectors is denoted by A vector dash. No, reciprocal of A is denoted by A vector dash, reciprocal of B is denoted by B vector dash, and reciprocal of C is denoted by C vector dash, respectively. How will you define it? Will be defined by the A vector dash. Definition will be the B vector cross C vector and then scalar triple product of all. Similarly, B vector dash will be the C cross A and then divided by scalar triple product of all these ABC. Now, and C vector dash will be the A vector cross B vector, then scalar triple product of all these three vectors. So what does it mean? Obviously, this A vector dash will be the perpendicular A vector, where A vector dash is what? Perpendicular to the plane containing B and C. No, between B and C, because B cross C gives the perpendicular vector of plane B and C. No, so similarly B vector dash will be the perpendicular to the plane containing C and A. No, and C vector dash is perpendicular to the plane containing A vector and B vector. So this reciprocal system of vectors has a properties. So some of properties are here as follows. Let A vector, B vector, C vector. A vector is a reciprocal of A, B vector is a reciprocal of B, and C vector is a reciprocal of C. Then if you will do the dot product, or if you will multiply it, you can say, or you can say dot product. If you will do dot product A with its reciprocal, then same A with its reciprocal, B with its reciprocal, C with its reciprocal, then you will get 1. No, if you will do dot product between the A with its reciprocal, that is A dash, B with its reciprocal means B dash, no, C with its reciprocal, then C dash, that is will be the 1. If you do indifferent, different than A with B dash, A with C dash, no, B with A dash, B with C dash, okay, C with A dash and C with B dash. If you will do with the different reciprocal system vector, then obviously you will get dot product 0. Let's illustrate it. For the illustration, we are going to take this one, no, and other will be as usual, as same. Okay, so illustration A dash we have taken, you need to prove 1, whether it will be the 1 or not. So A dot A vector dash, which is equal to A vector as it is, and dot A vector dash, by the definition of reciprocal system, you have B cross C by ABC. And obviously this A dot B cross C is a scalar triple product, that you can write ABC, and by ABC, if it will be cancelled, then will be the 1. No, and so on. Similarly you can, so on means similarly you can prove this one and this one. No, and after that you are going to if different with the different reciprocal system vectors, dot product will be then 0. So for that you are going to take this one, first one, A dot B cross A dot B dash, B vector dash, no, A dot B vector dash, which is A dash as it is, and then B vector dash, by definition you have C cross A by ABC, which is equal to this, you can write in a scalar triple product, that is AC and then A and ABC as it is in denominator, which is equal to 0. 0 why? Because this, if in a scalar triple product, if two vectors are same, in a scalar triple product, if two vectors are same, then it will be the 0. No, so 0 by ABC as it is. If you will divide with 0, 0 by A vector, B vector, C vector, then obviously you will get 0 and other will be same. After then, next property, second property you have, second property, okay. It says that if A vector dash, no, it says that if A vector dash, B vector dash, C vector dash is a reciprocal system of ABC. If this is a reciprocal system of ABC, then ABC will be also reciprocal system of A vector dash, B vector dash, C vector. This means converse way. Okay, if A vector dash, B vector dash, C vector dash is a reciprocal system of ABC, then ABC also will be reciprocal system of a dash, a vector dash, b vector dash, c vector dash. What does it mean? That means a, this means a vector can be expressed in this way. No, b vector dash cross c vector dash by a vector dash, b vector dash, c vector dash. B vector can be expressed in c vector dash cross a vector dash by a vector dash, b vector dash, c vector dash, and c vector can be expressed as a vector dash cross b vector dash by a vector dash, b vector dash, and c vector dash. Let's illustrate it whether it will be or not. So I'm going to illustrate for this one, first one. No, other will be same. Okay, for this illustration obviously I will solve the right side, whether it will be a or not. If it will be a, yes, obviously the a dash, b dash, c dash will be also reciprocal system of ABC. So for this I will go to calculate b vector dash and c vector dash. Okay, so we have b vector dash cross c vector dash. B vector dash, by definition you will have, by definition of a reciprocal system of vectors, you will have c cross a by ABC. No, and cross and c vector dash, definition, by definition you have a cross b by ABC. If you have any queries, you can check the definition of the reciprocal system of vectors. Okay, then what, how will you express c cross a and cross a cross b, and this will be a square. No, and now this is the vector product of 4 vectors, vector product of 4 vectors. And in the vector product of 4 vector, how will you, how is the expression for this? Then obviously c cross a, b, and then a as it is, c a same, first take b and then a same, minus, and then what you will be, ab is same, you know, ab is same, so ab is same in the both, so a c a b and then a as it is. No, this you have taken this with both c vector a b and then a as it is, minus, and then a with a b. Okay, a with a vector, b vector, c vector. Okay, a with a b and then c as it is, and denominator same. As you know that if any 2 vectors are same in the scalar triple product, that will be the 0. No, so this term will be 0, this one term will be 0. So what will be left? Then obviously you will get this will, you will get this, you can bring here at the right, twice you have changed, so ABC and then a vector as it is, and ABC of whole square. Then after the cancellation of this one, no, here you have ABC 1, here you have in the denominator you have 2, so if you will cancel, then 1 remain as it, 1 will be left, so a vector as it is by ABC. Now what is your target to solve? Now you need to solve for this one, a vector, b vector, d vector, c vector. No, a vector dash, b vector dash, c vector dash. If you will divide, then it will be a or not. So also now you are going to calculate this one, a vector dash, b vector dash, c vector. This meaning of this is scalar triple product. Then a vector dash and dot b vector dash cross c vector dash. Okay, and let's keep the values. So a vector dash, by definition of what is a reciprocal system of vector, you will have b cross c and by ABC, and the dot as it is. And what is your, what you have calculated for b vector dash cross c vector dash? You have calculated that a by ABC. No, b vector dash cross c vector dash, you have calculated a by ABC, so I will keep there. No, a by ABC. Now as you know, dot and cross can be interchanged, dot product is commutative. So dot product is commutative means what? You can bring front here a dot and b cross c as it is, and then ABC of whole square. And this you can write in a scalar triple product ABC and by ABC of whole square. No, one you will cancel, then you will get 1 by ABC. Your what is your target? Your target is to calculate this one. No, your target is to calculate this one. So now right hand side you have taken. Now this b vector dash cross c vector dash, by this you are going to calculate, which is equal to b vector dash cross c vector dash, you have calculated here, that is a vector by ABC. No, that we will keep a vector by ABC, and this denominator you have substituted 1 by ABC. If you will cancel this one, then a vector will be left. And similarly you can prove yourself, no, this one, for this one, whether this is a reciprocal system of converse or not. No, And now after the reciprocal system of vectors, I would like to go one problems. So find a set of reciprocal vectors of a vector, b vector, c vector. This reciprocal set of vectors you need to find. Set of reciprocal vectors. Reciprocal vectors, and we know that ABC is given, then A vector dash you need to find out. Reciprocal means B vector dash you need to find out, C vector dash you need to find out. For I am going to calculate for A vector dash. Obviously A vector dash formula you have B vector cross C vector and by A vector, B vector, C vector. So let's calculate this one, A vector, B vector, C vector. This is scalar triple product, that is A vector dot B cross C vector. How will you calculate? Obviously by the determinant form. Ijk component of A vector you will write here, Ijk, that is 2, 3, minus 1, and B vector Ijk component, and C vector Ijk component you will write in the third row. Now expand this. While expanding, 2 you will take here. Now you remove this row and column, then obviously you will get minus 1 and then 2, minus 2, 2 and then 2, and then negative minus 3. Obviously you omit this one, this row and column. What you will get? 1, minus 2 and minus 1, 2, and lastly plus, then minus 1 you will take. Omit this third row and first row and third column you will omit, then you will get 1, minus 1, minus 1, 2, 1, minus 1, minus 1, 2. Now expand it. After expanding this ABC, that is a scalar triple product, you will 3. Now this is non-coplanar. Okay, non-coplanar or independent we can say. So B, your target is to find. Now what is your target? This you have found. Now your target is B vector cross C vector, and then divide it, you will get answer. No, so let's then B cross C you have found. B cross C, how will you find? Obviously cross product of between two vectors, that is indeterminate from ijk, and B vector ijk component and C vector ijk component. Expand it, you will get 2i vector plus k vector. Divide it. After dividing, you will get 2 by 3 of I vector and plus 1 by 3 of k vector. Similarly, you can find B vector dash, okay, B vector dash and C vector dash in same way, same technique. So this much. Okay, thank you. This much for today. Okay, anyone have left the class, or due to electricity or due to net fluctuation or net problem, then you can manage from here. No, you can see the videos so that you can cover the chapters. Okay, thank you.